institutional.
Okay, good afternoon. My name is Pedro. I'm going to present the work for so if we are ready to written by me, by Mariano Goulart, by Bruno Guimarães, Luciano Salles, and David Monteiro from APNA, the Laboratory for Electronics and Microtechnologies in Federal University of Minas Gerais, and we are part of the National Institute of Semiconductor and Devices, the NCTDs. Okay. This will be presented in this order. First, we will talk about the active pixel sensor circuit, then the photodetector user. So then the experimental methodology used to analyze the selected structure. Finally, the results and the conclusion. Okay, motivation. The active pixel sensor is widely used in imaging sensors. However, the use of this pixel is with resistive element is not so useful. It can be very useful for dedicated applications, as with infrared detection, like with microbolometers or PIC, the continuous sensor, and with light detection, like with light-dependent resistor LDR in the visible spectrum, and which one was used in this work. Preparation. The modulated microelectronic circuit used is shown in this scheme, and its response is read on the out node. And a typical response is plotted on this graph of voltage versus time. And the general operation of this circuit is the transistor reset and transistor PS working as a digital switch, the transistor PX working as an analog switch, and the transistor buffer working as a common drain amplifier. The transistor PX is a selection transistor used in array applications, as well as the TX transistor that we will explain later. For now, the TX and TX transistor will always be on. So the reset transistor that was applied a period of this reset conductor, reset on, and a period of this reset off. When reset is on, the VDD voltage is applied on the sense node and over the photoresistor, except by some small drop voltages on the transistors. When this voltage on the sense node, it charges some parasitic capacitance formed by the gate bulk of this transistor buffer, and another by the source bulk of the transistor TX. When reset is off, we have a discharge of these transistors, discharge here, by a current passing through the photoresistor. The incident light defines the resistance of the photoresistor and the RC constant of the discharge. And all that is read on the transistor and on the PL node. Okay, the active pixel sensor used is found on the chip IR1, designed by our research group, the APNA lab, and made in a CMOS technology of 0.35 micrometers with some of that specifications, like the area and the supply, and with integrated photodiodes, photoresistors, and readout integrated circuits that we can choose to use or internal or external photodetectors. position. The test was performed at 300 Kelvin with 3 volts with the supply and a complete cycle of the reset of 1 millisecond. That 259 milliseconds of reset on and 750 microseconds of reset off. And was used external cadmium LDR as the photoresistive transducer. The test was performed on a test setup made with a boom laser and some lenses and mirrors that guide and create a homogeneous spot over the photodetector. The incident light was measured with a power meter device placed in front of the photodetector. And its incident light was changed with a neutral density filter, and its radiance ranged from 0.01 watts per square meter to 23.4 watts per square meter. And the control signals as the reset, TS and TX, were generated in a microcontroller, and its response of this circuit is read on the out node by an oscilloscope that was connected to a PC, a computer. The data from the oscilloscope to the computer were acquired with acquisition software designed, programmed by us to this application. Okay. The results were, when reset is on, we have voltage varying with the variation of the irradiance. And this variation here is plotted in the second graph of the voltage versus irradiance. That you can see that we have exponential behavior. That is usually called the logarithmic motion. And back to the first graph, when reset is off, we have the wave, right? And the key rate is proportional to the irradiance. Okay. Then to modify the proportionality factor of this discharge, we need to change the RC constant. So we associate a 1 nanofarad capacitor to the LDR and measure this response. Here in the period of reset on, we have basically the same response on the logarithmic mode. And in reset off, we have a small decay on the linear mode. We have the small decay here. Back to the TX transistor. Now the TX transistor is a transistor used in array applications that is used to keep the charge constant on the sense node. So it's allowed the use of the circuit in an array of the sensor that use a global shortwave. Okay, my first experience did with this circuit, this configuration, showed that with a high value of current, it forced the transistors, the X, to continue conducting. So to use this, here in red, so to use this functionality of the TX, we associate a series resistor to the photoresistor and measure the response now. With now we can see the charge was kept constant after the TX turned off, and gradually you can see. Okay, comparing this experiment with another did with a photodiode, we can see that after the TX is turned off, with a high current, we have a smaller time we could keep the charge constant on the sense node. And the current passing by a photoresistor is many times higher than a current photo-generated by a photodiode. So, we can reach these results with a photoresistive element. So we can use this with any resistive sensor or any device that changes resistivity to some environmental variable. The decay rate is defined by the RC constant. So to change this decay rate and allow other values of integration time, for example, we just need to change to associate the external device to this photodetector and as a parallel capacitor or series resistor. And we developed a methodology to use this pixel in arrays, in array application, and allow the global shuttling. And I would like to thank you to my team, the Altman Lab here on the floor. I would like to thank our supporters, the INCGs, SBMICRO, CAPS, CNPq, and FMG. And I would like to thank you for the attention.